In this video, we will discuss the use of scenarios within BOSfluids to create efficient and effective model variations. We'll begin with what BOSfluid scenarios are and how we can create, manage, edit, and review these scenarios, ultimately ending with a live demonstration on scenarios using BOSfluids. Allow me to introduce myself. I am David Tickner, a senior engineer at Dynaflow Research Group. Within BOSfluids, scenarios allow for the effective and efficient study of parameters, model selections, and actions all within a single BOSfluids file. The Model tab develops what is known as the main or base scenario, and within this tab we make the geometry changes and set up the base of our model. Upon developing our main scenario, we can continue to the Scenario tab. This tab allows the creation of scenarios, which are essentially copies of our main scenario, where we can edit a large array of parameters without affecting other scenarios. Through the organized use of these scenarios, you can manipulate your model to effectively and efficiently develop and analyze multiple model variations, all within a single BOSfluids file. To create a scenario, we have to first create our main scenario within the Model tab. This includes adding all the elements required and breaking up these elements if desired, as these actions cannot be performed within the scenario input. Once the main scenario is developed, the scenario variations can be made in the Scenario tab. Through the use of the plus button in the tab, you can create a new scenario. This essentially creates a copy of the main scenario for you to edit whatever parameters you desire. There is also a copy button available, and this will create a new scenario that is a copy of your selected scenario rather than a copy of your main scenario. Note that any changes to an element within the main scenario model will change the properties and parameters of that element for all scenarios. Now, when we have many scenarios, it becomes quite important to be able to track the differences between said scenarios. We can keep track of the differences between scenarios through various methods, and the most detailed tracker is the Scenario Manager. This can be found in the Tools menu named as Scenarios, or within the Scenarios tab through the pop-out icon. This Scenario Manager provides a tabulated overview of all scenarios and is populated with the parameter differences between these scenarios. Another tracking method is simply through the use of an apt naming scheme with succinct and factual descriptions. And the scenario names and descriptions can be changed when creating a scenario or through the edit icon on the Scenario tab or through the Scenario Manager itself. Furthermore, we have the Tool Actions menu as a tracking method, and this is again located in the Tools menu. This method allows for the evaluation of transient actions between scenarios, although this method only allows you to review the transient actions of one scenario at a time. Lastly, we have field selections, and this allows for the review of the parameters of your scenarios. However, again, only one scenario can be reviewed at a time. So, now that we have the various scenarios developed, how do we run the models? Well, the first step is to set up our analysis types with the appropriate settings listed there. Then we go into our Run tab where we can add our combination of scenarios with an appropriate analysis type. Running these analyses will then use your selected number of processes to run your analysis in parallel. And then BOSfluids will also use multiple processes on a single analysis if only one scenario is left being run. With the scenarios run, we can review and compare their results by either Control or Shift clicking on the analyses and the data we wish to evaluate. This helps us with performing quick and efficient comparisons of results and various scenarios. Here we have a part of a firewater system. The model has been simplified to only show the delivery of 6 firewater monitors, and with the routing further simplified through the use of 4 pipeline elements, which account for 1,000 meters of flow path each. If I set my diameter multiplier by to 4, we can have a better view of our system. And if I look towards the field selection, so show fields, change the scope to elements and change the field, we can see that our piping is all of 10 inches, with exception to the pump, which is a 8-inch pump. If we change this to pipe schedule, we can also see that everything is of a standard schedule. And then the rest of the model is made of steel piping, carrying water at 5 degrees Celsius, all driven by the single pump. And we have a upset scenario if we go to actions, where we see that this valve is being closed within 7 seconds. We zoom in here. We see that the valve just before the firewater monitors is going to close within 7 seconds. Now, we want to review the firewater system for various designs and upset scenarios and parameters. So how will we do this? Well, we'll do this by performing all of these upset scenarios and parameter changes through the use of scenarios within BOSfluids. Now, let's enter the Scenarios tab, and let's create our first scenario by using the plus button here, create a new scenario, and then we can name this scenario to whatever we want. So in this case, our first scenario is going to be changing the 10-inch piping to 12-inch piping. So we'll simply give it a name of 12-inch piping, and we click OK. Now, this first scenario, as we've created it, is just a pure copy of the main scenario. There are no differences. So we need to look towards changing this. So we will select all the piping elements and select show all fields. And we'll need to also make sure that we deselect the piping elements which are going to remain as 8-inch. We're going to change our pipe diameter to 10-inch by clicking off of that. But to 12-inch. By clicking off of that, we've now changed all of our piping to 12 inches. And then we need to also remember to change the reducer from 10-inch to 12-inch as well. And with that simple change, we now see that our piping is all 12 inches. So that's the very first scenario quickly created. Now let's look at the differences. Let's look towards a different scenario of what the water hammer results would be like if we increased the valve closure time from 7 seconds to 10 seconds. So again, let's use the plus button and let's rename to 10-inch 10-second valve closure. And we'll click OK. We'll then navigate to our valve closure. So we'll just do this through our closing valve. So we'll just do this through the action tab. And then we see our valve actions. And then we can set the time to 10 seconds for it to close. And click OK. And click Close. And now that's scenario 2 set up. And let's say we are also interested in how in the difference in the water hammer when the piping is at 12 inches with the valve closure at 10 seconds. We're going to do that here. We're going to, instead of using the create a new scenario, we're going to copy the selected scenario. So we're going to copy our 12-inch piping scenario, and we're going to call it 12-inch piping, 12-inch 10-second valve closure. And press OK. And, well, we can go back to our tools, our actions, and we see that our valve is, again, closing in 7 seconds, as that was what was in the original scenario there. And we'll set the time to 10 seconds. Now our valve is closing in 10 seconds, and our piping is all at 12 inches for this this scenario. Now, let's make one last scenario where we will, instead of looking towards all 6 monitors, all 6 firewater monitors being in use, we will create a case where there are only 3 firewater monitors in use. So we'll create a new case and we'll call this 3 FW firewater monitors. And we'll click OK. And so one thing is, in these scenarios, we cannot delete or break apart elements within the scenarios. But what we can do is we can set it so that we remove the elements from the flow path. And that way we remove them from this scenario. So if we remove them from the flow model and we click apply changes, so that's for these 3. Now it's going to keep showing them as filled in, but the reason for that is because I'm also showing the structural model right now, and I have not removed these firewater monitors from the structural model. But if I deselect the structural model, you can now see that we will be ignoring these 3 firewater monitors within the 3 firewater monitor case. And with that, we've completed our 4th scenario and our 4th and final scenario. All right, those are our scenarios set up, and now we're good to go forth and run the model. But first, let's review the scenario.